Hey guys, hope everyone is doing well. Welcome to chapter 5. This is one of my favorite and one of the most important chapters of the entire year. We go through a lot of really crucial fundamental stuff in this chapter. It's all about quadratics, and if you're not sure what that means, that's all right. Stay tuned, you will hear very shortly. But go ahead, get out your notebook, something to write on, work these examples, take notes, do what you got to do because this is really important stuff. 5.1, the section we're covering today, has to do with graphing quadratics. So before we get to what is a quadratic and how do we graph them and what do we need to have showing on our graph, I just want to show you and remind you something that you probably already know. Given a function, if f of x equals 2x squared minus 3x plus 1, as it says on the screen, how do we find the following values? How do we find f of 4, or f of negative 3, or even f of a squared, f of an expression? So quick review, and we've talked about this already, but wherever we see an x, because that was kind of the placeholder input, so we were saying f of whatever we plug in is equal to 2 times that thing squared minus 3 times that thing plus 1. Well, I'm going to go ahead and I'm going to align my colors. I'm going to plug in whatever is inside those parentheses. In other words, because I'm looking for f of 4 and plugging in 4, I'm just going to plug that in wherever I see an x. And then simplify. Now, the simplifying, I mean, it might seem basic, but there are a lot of little mistakes we can make. Should I do 2 times 4? Or should I do 4 squared first? Order of operations, do the exponent. So that's 4 squared is 16. So we have 2 times 16 minus 3 times 4, which is 12, plus 1. So that means 2 times 16 is 32 minus 12 plus 1. 32 minus 12 is 20 plus 1. It looks like 21. So we can say that f of 4 for this function is 21. Let's do another one. So f of negative 3 equals, and again, I'm just going to write out my whole function, except I'm going to be plugging in my red input, whatever's inside those parentheses, in for x. So 2 times negative 3 squared minus 3 times negative 3 plus 1. Let's do this. Order of operations, negative 3 squared, anything squared is positive. So negative 3 squared is positive 9, so we get 2 times 9. Negative 3 times negative 3 is going to be plus 9 plus 1. So 18 plus 9 plus 1. I look at this and I say 9 plus 1 is 10. So 18 plus 10, 28. F of negative 3 for this function is 28. All right, last one, f of a squared. So a squared is not a number necessarily. I mean, it's an expression. All we know is it's some variable a squared, and we're not even sure what a is. But does that affect how we approach this problem? Not really. The only difference is we might not get a perfect number numerical answer at the end, but I'm still going to take whatever's inside these parentheses, plug it in. So 2a squared squared. A squared squared is a to the 4th minus 3a squared plus 1. And you can see, kind of as we were discussing, it isn't something we can simplify down to just a numerical answer. Our final answer is going to have a's in it because we didn't know what a was at the beginning. So there's no way to simplify a's now at the end. F of a squared for this function is equal to 2a to the 4th minus 3a squared plus 1. So why do I show this to you? A couple reasons. One, because it's always good to review these things. Really important that we know how to plug things in. We were plugging things into a quadratic, and so if you weren't sure what that was kind of your light intro, and now I'm going to define it formally. So what is a quadratic function? It's any function that can be written in the form shown there. F of x equals ax squared plus bx plus c. A quadratic function has x squareds, but nothing bigger than that. No x cubes, no x to the 4ths, no x to the 5ths. It has x squared terms and nothing larger. And so anything that has this form, ax squared plus bx plus c, is a quadratic. So if we have this f of x equals negative 6x squared minus 7x plus 4, one of the things that we will need to do here very shortly is figure out, what does a equal? What does b equal? What does c equal? And if you're feeling a little confused and overloaded because you're like, wait, a, b, and c were something for standard form of linear equation. This is something mathematicians do. They reuse symbols for different scenarios. For linear equations, yeah, a, b, and c generally went to that standard form, ax plus by equals c. For quadratic functions or equations, ax squared plus bx plus c. A is the number of x squareds we have, so negative 6. B is the number of x's, negative 7. And c is just our constant, 4. And you can see where I got those from, hopefully from that blue function. And notice that it was really important, it is really important to carry along the sign, negative 6, negative 7, positive 4. Any function we can write in this form, ax squared plus bx plus c, is a quadratic function. Now, what do they look like on a graph? Because I said today was all about graphing quadratics. They always are shaped like parabolas. And a parabola, if you're not sure what that is, it's what's shown on the screen. It's kind of that arch, that either smiley face, so like an upside down arch, or a frowny face, so like a normal arch. It's always shaped like that. Sometimes it's at the origin, centered at the origin, kind of like it is on this third one, but sometimes it's top right quadrant, quadrant 1, or sometimes maybe it moved down to bottom left quadrant, but it's always that arch. Couple things that every parabola does have that you want to be aware of. Every parabola has a vertex, and this is a really important point on the parabola. The vertex is kind of that base of the parabola, or that peak, that highest point. It's, you can kind of think of it as the middle, in the sense that it's where, on this first example, let me grab my highlighter, we were going down and then we got to the middle and we started going up. And so it's where that change of direction kind of occurs. We were going up and now we're going down. So it's always that peak or that base of the parabola. You'll also see this red dotted line that I have drawn in there. And you might remember this term from Algebra 1, 2. But this red dotted line is called the axis of symmetry. And what does that mean? Well, parabolas by definition are symmetrical. They're the same on both sides. And hopefully you can kind of see that left of the vertex and right of the vertex are basically mirror images of one another. You could just flip it across that axis of symmetry. So every parabola has this axis of symmetry. And one thing you might notice just by looking at these parabolas is that the axis of symmetry actually always goes straight through the vertex, which kind of makes sense because we said the vertex was in the middle of the parabola. It's that very middle point. So the axis of symmetry, since everything's a mirror image on either side of it, that makes a lot of sense that it would be mirrored around that middle point. Axis of symmetry always goes through the vertex. All right, few things that you're going to want and need to know. Axis of symmetry, we can always find it using this formula. X equals negative b over 2a. Okay, and the b and the a are going to come from the equation we looked at earlier, ax squared plus bx plus c. So axis of symmetry is always at x equals negative b over 2a. It's an x equals equation because it's a vertical line. The x coordinate of the vertex, kind of unsurprisingly, is negative b over 2a because of what we just talked about, how the vertex is always on that axis of symmetry. So it would make sense that they share an x coordinate because the axis always cuts through that vertex. So kind of get 2 for the price of 1 there. Axis of symmetry, x equals negative b over 2a. That same value, negative b over 2a, is the x coordinate of your vertex. And then how do you get the y coordinate of a vertex? Well, once you know the x coordinate, you can just plug it into your function. If the x coordinate is 7, find f of 7, and that'll give you the y coordinate. If the x coordinate of the vertex is negative 4, Find f of -4, and that'll give you the y-coordinate of the vertex. So make sure you got those down because you're going to be using those on literally every problem today. Pause the video if you need to, and then let's get to some examples. So how am I going to graph this quadratic function? F of x equals x squared plus 2x minus 3. Well, there are a few kind of standard steps that we're going to take. The first one is find the axis of symmetry. So I'm going to come down here and say I need to know the axis of symmetry. I like to abbreviate that just AOS. I know it's an x equals, and I know that the equation was -b over 2a. So that just means I need to know what b and a are. So let me come up here and write down real quickly. I'll do it magenta. A is the number of x squareds we have. We have positive 1x squared. It's that invisible 1. B is 2. And C is -3, just that constant. So once we have those pieces of information, axis of symmetry, x equals -2, b, over 2 times a, which was 1. So x equals, it looks like -2 over 2, which we can simplify to be x equals -1. That is my axis of symmetry. So that's the first thing I like to do. I say, let's find my vertical line that I know will be kind of the center of my graph. And x equals -1. I'm just going to draw a nice dotted line there, dotted, dashed, however you want to think of it. That is my axis of symmetry. Now I also got something else as part of that calculation. I now know that the vertex, I'll use dark purple, the vertex is at -1 comma something. I know the x coordinate has to be -1 because the vertex has to be on that axis of symmetry. So how do I find the y coordinate? Well, if you remember, now that I know what the x coordinate is, I can just plug it in. I can say, what is f of -1? So that would be just like we did at the very start of the lesson, -1 squared plus 2 times -1 minus 3. -1 squared is +1 minus 2 minus 3. So 1 minus 5. So f of -1 is -4. We knew the x coordinate of the vertex. Now we can just plug in that y coordinate. The vertex is at -1 comma -4. -1 comma 1, 2, 3, 4. And I like to always just label that point. -1, -4. All right, so we kind of used everything that was over here on the left, except for this last one that I hadn't really revealed. And it's kind of an optional one. It depends where on the graph you are, whether or not you want to use this. But the y-intercept is always the c value. And so you can think of this, you can reason this out, because think about how we found the y-intercept in the past. We've said, well, the y-intercept is when x is 0. So what happens if I plug in 0 to my function? If I plug in 0 to my function, 0 squared is gone, 2 times 0 is gone, and all I'm left with is that c value. So I do know, just kind of for free, that my y-intercept, I'll go ahead and list it over here, my y-intercept is going to be at 0, -3. 0, -3. My c value. If you're close to the y-axis, you can use that trick. If not, you might not want to use that trick because then it'll make your graph huge. Now, I talked about getting something for free. I talked about, getting the x coordinate of the vertex for free after the axis of symmetry. I actually know 3 points on this graph. Remember that parabolas are symmetrical. So I've got my vertex, -1, -4, and then 1 unit to the right of it, I went up 1. I went up 1 from the vertex. So that means that 1 unit to the right this way should also be up 1. When graphing parabolas, I'm going to ask you guys to have 5 points total. And you might say that sounds like a lot, but the vertex you have to find. And then if you just find 2 on one side, you can reflect them over, and then you have your 5 total, because you'll have 2 on one side, 2 on the other side, plus the vertex, and we'll have it. So I just need 1 more point, and then I can draw this parabola in. I'm gonna just try to figure out what would I get if I plug in x equals 1. I'm just moving my way to the right 1 more unit. So I'm gonna say, okay, what is f of 1? I'll go ahead and do that over here. F of 1 equals 1 squared plus 2 times 1 minus 3. So that's a 1 plus 2, but minus 3. So 3 minus 3. F of 1 looks like 0. So if f of 1 is 0, that means I can go 1, 0, and that's a point on my parabola. Which means then I can reflect it across the axis of symmetry. And now I have my 5 points. Now I can, oh gosh, that was terrible. That was still terrible. Drawing these guys in is not something I'm awesome at, but something like that. Notice it's not like absolute value. They're not straight lines. It is a curve, and it gets steeper and steeper as we go away from the vertex. So this is just your first example, how we can find the vertex, how we can find the axis of symmetry, and find other points. We're just going to plug x values into our function until we have 5 points to sketch in that parabola. So let's do another one. And you'll notice in the instructions, it talks about making a table of points, just a little bit more structured than all my work going all over the place. So graph this function by making a table of points. F of x equals negative x squared plus 2x plus 3. Well, before I do anything, before I even start my table, I need to know where is my axis of symmetry, where is my vertex. So that's going to be the first thing I do. I'm going to say, okay, so axis of symmetry, I know it's x equals negative b over 2a. And so I'm going to come up here and say, so a looks like it's negative 1 here because we have negative x squared. B is 2, c is 3. So axis of symmetry, x equals negative 2 over 2 times a, which was negative 1. X equals negative 2 over negative 2, x equals 1. That is my axis of symmetry, and I'm going to go ahead and fill that in. Because now I know where I need to mirror things around. I need to mirror them around this axis. Let's find the vertex while we're at it. We know that the x-coordinate is 1, so I'm going to say I can find the vertex, and I'm going to start my table. And I'm going to say, okay, 1 is going to be in the middle of my table because the vertex is in the middle of my graph. I know that I need to plug in 1. So I'm going to plug it into my function. Negative quantity 1 squared plus 2 times 1 plus 3. So negative, but we got to do the 1 squared first. So 1 squared is 1. So negative 1 plus 2 plus 3. So negative 1 plus 5 looks like 4. So 1 comma 4 this time is my vertex. So I'm going to label that 1 comma 4. So now that we know that, we can just make a table of points, and we just need 5 points, remember. So I'm going to say, I know that 1 is my middle. I'm just going to go negative 1, 0, 1, 2, 3. And the good news is I don't have to plug all these in. I can plug in 2 of them on one side and then just reflect them over. So I'm going to plug in 0. So I love plugging in 0. It's a really easy one to plug in because negative 0 squared plus 2 times 0, I know those will disappear. Plus 3, it looks like 0 comma 3 is a point here. And if I know 0 comma 3, there's that y-intercept, the c value. I went left 1 from my vertex and it went down 1. I'm going to go right 1 from my vertex and it'll go down 1 because it has to be symmetrical. So that means 2 even without plugging in, I know the y value is 3, 2 comma 3. Do you want to plug in -1 or 3? You know, I might plug in 3 just because I like dealing with positive numbers. So -3 squared plus 2 times 3 plus 3. So again, we got to do the squared first. So -3 squared is 9 plus 6 plus 3. So -9 plus 6 plus 3, that comes out to be 0, -9 plus 9. So 3 comma 0 is a point on my parabola, which means, okay, I went down 3 and over 1 from my last point. I'm going to go down 3 over 1. It has to be symmetrical. So 2 away from the axis of symmetry, I'm at 0 on either side. So that means -1, I don't even need to plug it in, will be 0. And now I've got my 5 points. And I can sketch out I'm not good at sketching parabolas, but you can tell what it is. It's this upside down facing parabola with a vertex at 1 comma 4. So a couple things here. What made it upside down? Well, you might have had a hunch about that. If we have -x squareds, it will be an upside down parabola. It will be opening downwards. When we had positive x squareds, positive, even though there's no plus sign there, we know it's by default positive. We had an upwards facing one. So upwards facing parabolas have positive x squareds. Downwards facing parabolas have -x squareds. Something good to know, something you'll want to commit to memory, put it in your notes. And so here we go. We got a little more information kind of related to that. Every quadratic function will have a minimum or a maximum value, but not both. And think about why this is. If a is positive, so if we have positive x squareds, we know it opens up, and maybe it looks like this. Well, it goes up forever. So there's really no maximum value because it keeps going up forever and ever and ever and ever and ever. But what do we have? We definitely have a lowest value. We have a minimum value if it's opening upwards. And hopefully that kind of makes sense intuitively to you. If we're opening upwards, we do have a lowest value, but we don't have a highest value because we can always go up further. On the other hand, if we had a downwards facing parabola, meaning a is negative, we will have a max value. Because here we have definitely a highest point on the graph, but we go down forever. So a lot of the times, the interesting part, the important part of the graph is going to be this min or max value, which happens to be the vertex. And you can think about that and wrap your mind around it pretty quickly, hopefully, and say, yeah, that's true. The vertex will be the min or max value of my parabola at all times. So here we go, last problem. Just a couple new questions along with graphing it. F of x equals x squared plus 2x minus 2. I want to know, does it have a minimum or a maximum? I want to know the domain, the range, and I want it on the graph. Let's start with that first part. Notice that it is a positive x squared. If it's positive, we know it's going to look something like that. It's going to open upwards, right? So if it opens upwards, then what do we know? Well, we know that there is a lowest point. We know there is a minimum, but it goes up forever, no maximum. So that one wasn't too hard. Let's graph the function, and that'll give us kind of the rest of the story. So I'm going to start by finding my axis of symmetry. X equals negative b over 2a. So b looks like 2, so negative 2 over 2 times a looks like 1. We have 1x squared. X equals negative 2 over 2. Axis of symmetry here is x equals negative 1. And I know we've seen that a couple times on these notes. It won't always be 1 or negative 1. I just tried to keep the numbers kind of simple for this this intro. So x equals -1, that's my axis of symmetry. I can use that to find my vertex, start my table, and say -1, what do I get when I plug it into my function? So that means I get x squared, -1 squared, plus 2 times -1 minus 2. -1 squared, anything squared is positive, so that's a 1 minus 2 minus another 2, so 1 minus 4, 1 comma -3 is my vertex. Sorry, -1, -3. So -1 comma -3 is my vertex. I know that that means I just need to go something like this. And then I'm probably going to plug in 0 and 1. 0, because I love plugging in 0. 1, because it's a pretty easy number to plug in. So if I plug in 0, 0 squared plus 2 times 0 minus 2, -2. Those zeros are gone. And because of symmetry, because of my axis of symmetry, I know that -2 comma -2 is another point on this graph, just reflected across that line. I'll plug in 1. So 1 squared plus 2 times 1 minus 2. So that's 1 plus 2, but minus 2. So 3 minus 2 is 1. So 1 comma 1, which means on the other side of my table, other side of my graph, it's symmetrical. It should also be 1. And here we have our parabola. So a lot of good things going on here. We know what the parabola looks like. We actually know what the minimum is too. We knew there was a minimum. Now we know what is that lowest value that we get. Well, I'm going to say the minimum is -1 comma -3. And sometimes you might be told that the minimum is just -3 because the minimum is how low on the graph does it go? What is the lowest point it goes? It goes to y equals -3. That's the lowest spot on the graph. Where does it happen? When x equals -1. So -1 is where it happens. -3 is the minimum. Let's talk about these two words. We've seen them before. They are not going away. What is the domain of this function? What x values can we plug in? Well, guys, I'm going to give you just a little hint cheat. On a quadratic, the domain is always going to be all real numbers because we can plug in anything here. It goes forever left. It goes forever right. Sorry, I did those backwards. It goes forever left. It goes forever right. We don't skip anything. We can plug in any x value to this function and get a y value result out of it. So domain is all real numbers. And you can write it with that fancy R. You can write from -infinity to +infinity. You could write -infinity is less than x is less than +infinity. All those ways that we've kind of seen it written. What is the range? The range is not all real numbers, and it never will be for a parabola. The range is what y values are we hitting on this graph. And it has to do with that min or that max, because think about it. We know that the minimum, the lowest we go is -3. And then we go up forever, and the range has to do with those y values, right? So looking at this, I say, I'm going to hit every y that is greater than or equal to -3. Every y that is greater than or equal to -3, because I'm hitting -3, that's my lowest point, and I'm going up forever. So I'm going to hit everything there. I'll also put it in interval notation, -3 with that square bracket to say include -3 all the way to infinity. We could write -3 is less than or equal to y is less than infinity. Again, just showing you all those different ways to write the range. But what y's are we hitting? All the y's greater than or equal to -3. Graphing quadratics, kind of a fundamental skill. You have to be able to find the axis of symmetry. You got to know how to find the vertex from that, how to make your table, plug in points, find 5 points, and also now know how to find the minimum, maximum, or the domain and range. And so all of these pieces are going to come together. 5.2 is actually really related to 5.1. That'll be a much shorter video, I think. But if you need to, rewind, watch something again, get something down in your notes. I'm hoping you're working these problems. Guys, this is where a lot of new material is going to be hitting you for this course, is chapter 5. And so we're going to have to take care to do a really good job with our notes and make sure we're comprehending what's going on here. That is all for today. If you had questions on any of this, be sure to write them down so that you can bring them up next time we meet in person, and you can ask them and get clarification on them. But hopefully 5.1, you got a good feel for that. You'll have some practice problems. Let me know if you have questions, and have an awesome day.